Lesson 5.3, we're going to be solving quadratics by factoring. And we'll spend a few days on this lesson. First of all, the factored form of a quadratic is 0 equals a, and that is our normal a value, and then x minus p times x minus q. And then p and q, a positive p and q, would represent the x-intercepts. Now the reason being, again, is that if you put p in here for x, p minus p is 0, and that's what we want it to equal. Now, for example, in this parabola, we have a parabola here with a vertex of 4, -4. You can see it crosses the x-axis at a positive 2 and a positive 6. So 2 and 6 would be considered the x-intercepts, which is also the zeros of that parabola. So therefore, the factored form of this, since 2 is a 0, positive 2, then x minus 2 would be a factor, because positive 2 makes that equal 0, and 0 times anything is 0. And likewise, since positive 6 is a 0, x minus 6 would be a factor. So this would be the factored form of that quadratic. Now, changing this to standard form, we need to multiply these together. And to do that, like we typically would do, we would distribute. So I'm going to take the x times the x, which would be x squared. I would take the x times the -6, which is the -6x, the -2 times the x, which is -2x, and the -2 times the -6, which would be positive 12. You can see we then have like terms. So we'd have x squared minus 8x plus 12. And that would be the quadratic in standard form of the graph above that has 2 and 6 as x-intercepts. Now, when multiplying two binomials, now a binomial is something that has two terms together, we can use the acronym FOIL to help us organize our work. So for example, FOIL standing for first terms. Those first terms would have been this x times x. And then the outside terms, which would be the x times the -6. The inside terms, which is where that -2x comes from. And then our last terms, which would be the -2 times the -6. So it's just an acronym if you have two binomials on how to multiply those together. So a couple examples, and these are right off of the 5.3 study guide. This is page 17 in your packet, where they're giving you the roots, and you're to write the equation in standard form. So for number 1, 3 is a root or a 0, which means that x minus 3 would be a factor. -4 is a root, so x plus 4 would be a factor. And then to change the standard form, we would FOIL. First terms would be x squared. Outside would be 4x. Inside would be a -3x. Last terms would be a -12. Combining like terms, you'd have x squared plus 1x minus 12 equals 0. Now, number 4, we've got -5 as a root, and that is the only root. So if you think about this, this parabola must be crossing at -5, and therefore that must be also the vertex of the graph. So we consider negative 5 a double root. So in that case, we'd have x plus 5 as a factor twice. Then foiling, we'd have x squared. We'd have 5x, and a positive 25. Combining like terms, get 10x, and this would be the quadratic that has that negative 5 as a 0. This we'll talk about a little bit later. This is called a perfect square trinomial, a special case that we're going to work on later this week in factoring. Number 7 involves a fraction. Now, this is a big change, and I think this will help you, as the textbook talks about writing this as x plus 1/3. And then you get fractions involved. All right, but if a negative 1/3 is a solution, that means that we would have to have a positive 1, and then this would be 3x. That would be the same thing as if what you'd get if you multiplied this one by a positive 3. The reason being then is if you set the 3x plus 1 equal to 0, and you subtract 1 and divide by 3, then negative 1/3 is your root, or 0. The plus 5 we would just write as x minus 5, and then we would FOIL. So I'd have 3x squared. Outside terms would be negative 15x. Inside would be 1x. Last terms would be negative 5. Combining like terms, then we'd have 3x squared minus 14x minus 5 is equal to 0. Number 10 here, another example that involves a fraction. So one of the factors would be x minus 3. And then 2/5, we'd have to have a minus 2, and we're dividing by 5, so I'd have to have 5x minus 2. And as you can see one more time, the reason for that is if I add 2 and divide by 5, I do get that 0, or solution of a positive 2/5. Then I'm going to FOIL, so I've got 5x squared minus 2x minus 15x plus 6. If I combine those like terms, I have a negative 17x for my outsides and insides combined. And this would be my quadratic that has those given solutions. 13 is a special case here. We got a positive and a negative, same solution. So this is going to be, again, minus 2. We'd have to have 3x. This one we'd have to have positive 2 with 3x. And now foiling, I'd get 9x squared plus 6x minus 6x minus 4. You can see that the like terms cancel, and we're left with 9x squared minus 4. So there's no b value in this quadratic. This special case is difference of squares. Because it is the difference, it is subtraction. And then we have 9 as a perfect square and 4 as a perfect square. Remember those perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Number 16 here, we have negative 7/8. So I'm going to have positive 7, 8x plus 7. And then I would have a minus 7 with 2x. And then I would FOIL, so I'd have 16x squared minus 56x plus 14x minus 49. Combine those like terms, I'd have 16x squared minus 42x minus 49. And that would be the quadratic that has those specific zeros.